So read through the materials section, make sure you have everything that you need, and for the tape, I would not use duct tape, maybe masking tape if it's not too sticky, because you're going to have to remove this tape from the filter paper, so you don't want any tape that's too strong. So the paper chromatography, we're going to analyze food dyes and from our data to determine the identity of an unknown dye. It's going to be really important that you read this procedure more than one time and then also refer back to the exploration page where it explains how to calculate the RF. So let me just review a few things. On your filter paper, it asks you to make these 9 different lines. You really only need 7 lines because you need places for the 6 dyes and you want them to be separated by at least 1.5 centimeters and then an unknown. So you have a total of 7 dyes you're going to test, and those dyes are going to be placed as dots on the bottom of this filter plate paper, and they need to be separated from one another by at least 1.5 centimeters. So it tells you to create a baseline by drawing a thin horizontal line with a pencil. This is super, super important. If you use a pen, the dyes in the pen will travel along with your solvent potentially. So use a pencil, and then you're going to put that at the bottom of the paper, 10 millimeters or 1 centimeter from the bottom. And so just use your ruler to put that line straight across, and then draw the 9 cross lines with the 1.5 centimeters across as it says, but you will place your dyes, you'll only use 7 of these little spots. Okay, so use your ruler to figure out 1.5 centimeters, and then from left to right, so maybe starting not at the end, but maybe over here, 1, 2, 3, 4, 5, 6, 7, to give yourself some extra space on the ends. Label the 6 FD and C food colors according to these abbreviations. So B1, so put B1 in pencil here, B2 in pencil right here, R3 in pencil, Y5 in pencil, Y6, and then UK, which stands for the unknown. Then put your safety glasses and your gloves on, and then for each of the dyes, you're going to place them in this well. So they're labeled, and you should be able to tell which one is which. And then you're going to take your toothpick, and you're going to take a drop of the dye and put it above the appropriate label. So for blue 1, you'll take your toothpick, put it, stick it in the well here, and then put a little dot on the pencil line above where it says B1. And the more concentrated and the smaller this dot is, the better your results are going to be. So you'll want to put more than one little mark on, like take your toothpick, put a small little dot, let it dry, take your toothpick, put another dot right on top of that dot, let it dry. Okay, and then also make sure that you're putting it in the center. So we see here's an example, B1, B2, R3, R4, Y5, Y6, UK, all in pencil, and then above it is the dot. So the smaller the dot and the more concentrated the dot, the better it's going to be. And then you'll use a clean toothpick for each new dye. You definitely don't want to use the same toothpick throughout. As soon as you have transferred one dye, throw that toothpick out and use a new toothpick to transfer the new dye in your little dot. Once your paper is spotted with all the dyes, allow the spots to dry, and then you want to place your filter paper in a column and staple it together. And it says you may want to tape it here to allow you to staple it better, and then remove the tape afterwards. So you don't want to use really sticky tape. Then you will have prepared some salt water. You'll place that salt water in the Petri dish, and then you'll place your column of filter paper inside it. Now your dot should be on the inside, and the level of this mobile phase or your salt water should be well below your line where you have the dots. And so what's going to happen is the paper is going to absorb the salt water, and as the salt water travels up the filter paper, it's going to carry the dyes with it at different to different lengths. So when the solvent has traveled about 2 centimeters from the top, remove the filter paper cylinder and immediately mark the solvent front with a pencil. Otherwise, it's going to evaporate away and you won't know where that solvent front was. After the paper is dried for several minutes, carefully remove the staples and draw an outline around each spot using a pencil. So on the Explore page, there is a little graphic of what your filter paper may look like. There's only 4 dyes here, and yours will have 7. But the spots may vary in length, and they will vary where they are on the paper, and just circle those in pencil. All right, then what you're going to do is you are going to measure how far the dye traveled. So you will start from the pencil baseline where you had the dots where they originally began, and then measure up to the middle of the dot of where the dye is. So you would measure from here to the middle of the die. Now it tells you to measure in millimeters. You can measure in centimeters. That's fine. It really doesn't matter. Since you already measured in centimeters last lab, centimeters is fine. So to calculate RF, the distance the compound moved over the solvent front distance. And the solvent front distance will be from the bottom of the paper up to the solvent front. And it should be the same for every single dye. So as you're calculating the RF, the distance the dye moved divided by the solvent front distance, which should be the same for all of them. And if you measure in centimeters and centimeters, your units of centimeters will cancel out. And so then you'll place your information in data table 1, the solvent front. It says in millimeters. You can do centimeters if you like. This will be the same for all of them. Spot 1, RF. Spot 2, the millimeters and then the RF, the millimeters and the RF, the millimeters and the RF, or the length. And so what those different spots are, if there's spot 2, spot 3, some of the dyes may separate into several different colors. So for example, the blue may have, or if you have green, there may be blue and yellow. So there's room in your data table if your dye separates into more than one color. So it's not going to happen for all the samples. So not every sample will have more than one spot. Okay, so I hope that makes sense. So when your dye travels up, it may separate, and if it does, you'll have 2 spots or 3 spots, and then 2 or 3 RF factors. So you can answer those questions and then fill in the data tables, and don't forget to take a picture of your finished chromatography paper.